back to the beginning from scratch, so we make sure we have it covered. I am Pete Meyer, Technical Editor in Motor Age Magazine. I'm here with the President of the Automatic Transmission Service Group and Powertrain Pro publisher, Wayne Colonna. He's a little under the weather tonight, a little laryngitis, so kind of bear with him. He was not the reason that we lost all audio, so I can probably blame it on him since he can't get to me that quickly. So without further ado, Wayne, I'm going to go ahead and let you go, and in the meantime, I will see if I can rescue others from the furthest reaches of cyberspace. Right? So
thank you, Pete. And once again, I would like to thank all of you who have joined us for this evening's presentation about general transmission diagnostic tips. And of course, I'd like to always thank our sponsors for making this evening's presentation possible. One of the most widely asked questions I hear when it comes to transmission diagnostics is it the transmission or not? And I think the second most widely asked question I hear is, which scanner should I own? And neither one of these simple questions have a short, simple answer. One of the responses I do have when it comes to scanners is, the question you should really be asking yourself is, what type of scope should you own? Because you will definitely nail down more issues with a scope than you will with a scan tool. But when a transmission is malfunctioning, a legitimate starting point is to ask, is it the transmission or not? But after that, a diagnostic approach to a particular problem can vary depending on a number of factors. Some of the major contributing factors that could shape a diagnostic approach would be the year and make of the vehicle, of course, but then again, the level of expertise of the tech and the type of equipment available for use. Of course, the year and make of the vehicle not only determines the type of transmission being diagnosed, but it also determines the operating system of the vehicle it works within. For example, is the ABS the primary source of vehicle speed being broadcasted over the network? Or is it a Hall effect or an AC voltage generator located in the differential, the transfer case or transmission? Does it have a mechanical TPS or drive-by-wire? Is there a dedicated TCM, or is it integrated into a PCM? You know, the transmission itself could have the computer built into the transmission, like a mechatronic assembly or a TECM, or it could be bolted directly on the transmission, like the Toyota U660 or the Ford TF81 SC, or it could be remotely located somewhere in the vehicle. And just this factor alone changes how one would approach a solenoid electrical fault. And this was just a simple example as to how a diagnostic approach can change based on the type of transmission and the operating system it works within. The various differences are considerable. But then there comes into play the level of expertise of the tech. You know, does he or she know how to read hydraulics and wiring diagrams? And can they interpret pressure gauge readings? I think if you can interpret this one, you're pretty good. Anyway, can they record movies with the scan tool perhaps, and then be able to interpret that scan tool data? You know, can the tech operate scopes and meters effectively? Is there a comprehensive understanding of various sensors, inputs, and computer command outputs? Is there a comprehensive understanding of solenoid to planetary power flow? The level of expertise of an individual determines the optimal use of a diagnostic equipment that's on hand in the shop. And you know, I've seen the extreme where a shop has a variety of scanners, meters, and scopes, and no one knows how to use them beyond pulling codes. Yet on the other hand, there is an extremely capable individual in the shop but lacks the equipment to do their best. But with all this in mind, one can completely understand how difficult it is to answer, is it the transmission or not? However, in light of these variables, there are general tips in diagnosing problems that can be utilized in a wide variety of cases, which is the intent of this seminar. These general tips that I'm going to offer up have been pretty much developed over the years from working on the technical helpline here at ATSG. These tips will cover not the most common questions to ask the customer, to tips about trouble code. We're going to have several points throughout the presentation about trouble code. The importance of power and grounds, obviously, wiring and electrical devices, and what to do with the lack of scan tool data. And then some sensor signal tips. But first of all, we'll start by briefly running through a typical checklist so that it can be contrasted with what I call not the typical checklist. And I cannot emphasize enough from doing tech calls the amount of headaches that can be avoided if the right questions were asked. The not the typical checklist was developed from experiences we have had with the tech line. And I'm going to tell you, hindsight is always 20/20 vision. So the intent is to be able to have foresight with this kind of a list. Now, a typical checklist usually begins with acquiring customer and vehicle information, of course, and asking the driver what is the complaint, followed by when did you begin to notice the problem. Usually at this point, maybe an inspection is made of the fluid level and its condition. You know, now pulling codes may be next, and we're going to get into codes a little bit later on. But at some point, a road test is usually performed to verify the complaint, followed by a visual inspection while driving. I mean, like here we see both the neutral and drive light lit up at the same time, so we got an obvious problem here. Here, the light indicates that we're in park, yet we're driving down the road 28 miles an hour. We got some obvious problems here. And of course, we check for leaks, bad mounts, U-joints. We might be looking for linkage issues. And after all this, there still may be a need to do some pressure testing, electrical testing, maybe even to do some bulletin investigations before it can actually be determined if the transmission will need to come out or not. But now, let's run through the not the typical checklist, which I have to tell you I think is really going to be helpful if you don't have some of these questions already in mind. The very first thing is to ask the customer if the vehicle has had an aftermarket tuning program or chip installed into the computer, or if it had a recent programming done at the dealer. We had, for an example, a shop out in Everson, Washington, where a Dodge diesel with an incomplete chassis using the Eisenseiki 68RC transmission came into the shop. It was totally destroyed. After rebuilding, the transmission had sloppy shifts. And of course, the tech tried to have a factory scan tool reset the shift adapt, but they would not reset. They were frozen. And he was about ready to buy a new TCM, but when he called the owner to discuss the possibility of a new computer, all of a sudden the owner started to say, you know, I installed this tuner program into the computer through the ALDL, and after I did it, it shifted great, but over time it really disintegrated. Well, so did the transmission. But the tool to install the tuner could also remove the program. And when they did, the adapts could be reset, and the transmission shifted perfectly. Now, could you imagine the shop owner buying a new TCM? Of course, everything would work well. And what do you think the owner would do once he got his truck back? Install the tuner back into the computer, which would lock the adapts and burn the transmission out while it was under warranty. Well, the problem here is that the tuner works really good with full chassis vehicles using Chrysler's 48 RE, 45, 545, and 68 RFE transmission, but not the Eisenseiki style units and incomplete chassis. But this is a good example as to why it's good to ask this type of question. Now, when it comes to factory programming, we've run into issues where a particular vehicle could have either one or another type of transmission in it. And we have seen when the programming was done, the wrong transmission somehow was identified in the program, and now all of a sudden the vehicle has a completely opposite shift pattern. We've seen this happen with 4L60Es and 4L80Es and GM. We've seen it with AX4N, AX4S transmissions and Ford. So again, it's really a very good question to ask. Now, one tip to see if any alterations was made to engine performance would be to compare the engine torque PID in a scan tool like you see here compare it to factory specifications, because engine torque, you know, it's a combination. It's an engine load based on TPS, mass airflow. It's great for identifying non-OE calibrations. You know, if you compare the torque under load with advertised engine torque ratings, and if they don't match, well, either there might have been some programming done, or maybe you do have some engine load problems. So at least you have a clue that something is wrong. Now, another question to ask, of course, is any previous work done on the vehicle, and I mean any kind of work, not just transmission. Maybe of course, engine, under the hood stuff, brakes, ABS, but especially collision repair. Man, there's so many times we've had work done in a collision shop, and it has hid problems with electrical wiring. And so if you have some clue as to where maybe the work was performed, you could get pointed in the right direction. Now, here's something that's very good to do. Always check tire sizes. Make sure that you have correct tire size, and I suggest using a stagger gauge. It's just so quick and easy to do, and you can ensure that all the tires are of equal size within like 1/8 inch of each other, especially with 4x4s, all-wheel drives. I mean, when you have the wrong tire size, that transfer case becomes overactive, and you have premature failure of the transfer case. We have quite a number of vehicles now that have that curve recognition program where, you know, once you're in a turn, it does not want the transmission to shift. So if you've got some tires that are overinflated, underinflated, maybe 3 worn tires and 1 good spare on there, now the computer will initiate a curve recognition program as you're going down the road straight, and the heavier in the throttle, the less it will upshift. So really, tire sizes are critical. And now, of course, you should also ask the customer, was it in a flood? And I know that sounds kind of ridiculous, but keep in mind, customers do not like telling you the whole story in fear of a higher repair bill. So, you know, you really got to try to work these things out of them. Also ask if there was any aftermarket gadgets recently added, especially because they could have done something that's completely hidden and out of view. And again, these are questions that, had shops known this before doing the work, could have saved them enormous amount of headaches. Fluid changes, additives, gasoline, just so many things. Like Honda, you've got to make sure you got OEM Honda fluid in that thing. Otherwise, Hondas are going to have very abrupt shift. Engine oil. I mean, we take a 2.4 liter Chevy Cobalt with variable valve timing. It'll sport a P0010 code or a P0011 code for a camshaft position actuator solenoid system performance. And these codes will absolutely cause high line pressure, making harsh shifts inside the transmission. I had a situation here in Miami at Alonzo Transmission where it was a BMW 7 Series. The vehicle came in, had to have some repairs done, and then they were calling us here at ATSG with a severe problem with the converter clutch. At least that's what they thought. I mean, it was so severe that it actually felt like somebody was inside that transmission with a sledgehammer beating it up against the flywheel. And of course, I went there, and I got to tell you, it was remarkable. While idling in park, I mean, the banging that was going on was so dramatic that the steering wheel was actually vibrating. And what it turned out to be was that when the car came to the shop, it came basically almost in fumes. And so on a road test, they had to put gas in it. So they loaded it up with some cheap gas. And that BMW 7 Series did not like it. And they were confused, thinking it was some kind of converter clutch issue. So, you know, fluids, additives. I think the funniest thing that I've seen people put in transmissions was somebody was told that the egg white egg white would actually stop the transmission from leaking. Well, I'll tell you, it makes a really good omelet, and it gets sucked up on the filter, and then the vehicle doesn't move. So anyway, those are some good things to ask. You know, where is it parked? Is it under a tree in a barn? Squirrels or rats, they love to eat wires. You know, so if you've got a chance of some kind of an animal in there chewing away wires, and you've got yourself an electrical problem, it would be nice to know that, especially if you see some nuts hanging out on top of the car. But anyway, but how is the vehicle driven? On some rare occasions, we've had scenarios where, you know, the customer's complaining of a shifting problem. And of course, at the shop, they never had the problem. They give it to the customer. A couple days later, he's back again, and only to find out after maybe 3 weeks, 4 weeks, a month, whatever, you find out that the problem only happens at a specific spot in the road as he's going to work and coming home from work, and he's passing these high-power tension lines, and it's affecting the shifting. And so, you know, sometimes asking these questions, all of a sudden, they realize that, you know, there is a consistency as to when the problem was. We had another situation here in Miami where a Mitsubishi the guy was complaining about it not having any movement forward. But, you know, he'd bring it there, it would work fine, and give it back, and then he would complain every now and again it wouldn't move. Well, long story short, it turns out that there was a compromised ground wire in the trunk for the taillights, and when the headlights were on, electricity, finding a ground path, would work its way through the reverse light signal, and now the computer would see that the transmission was in both drive and reverse, and purposely wouldn't let the transmission engage as a safety feature. But it would only happen when the headlight's on. So, you know, sometimes asking these questions can really pull out some answers that you might need to be able to diagnose some of these problems. And, you know, like I said, oftentimes answers to these questions take place after the work has been completed and the real problem surfaces. So remember, hindsight is 20/20. Make it your foresight with some of these questions. Now, we talked about pulling codes earlier. By the way, you'll see a lot of pictures using the Genesis throughout this PowerPoint, and the reason for that is it's such an easy scan tool to take a picture of. The screen is big, and it really helps with the PowerPoint presentation. So that's why you'll see that here. But anyway, if you're not pulling codes, or you are pulling codes, I do recommend that you do a complete system health check and scan the entire system for codes. And the next step is to prioritize your codes, and I call that learning how to diagnose your diagnostic codes. I'm going to have a simple example right at the end of this presentation about that, just a simple one. I could actually probably do a whole webinar on diagnosing diagnostic codes and learning how to put them in priority. You know, try to see how one code may be caused by another, or that how maybe there's something wrong with the transmission that caused those codes, which I'll explain what I mean by that shortly. And of course, you know, it's good to write down all the codes to document them, and I personally like to do that, and then I erase them all, and then I drive the vehicle to see which ones return immediately, and that helps me to begin to prioritize, you know, what's kind of going on with the vehicle. Now, this next point, I just can't stress enough either. And battery testing only takes minutes to do. Just like it would only take minutes for you to take a stagger gauge and measure tire sizes, to actually clean maybe the battery and do a load test on the battery, you won't believe how many problems that you will solve just by starting here with the battery. And you know, not just doing a load test on the battery to see if it's any good, but to really make sure that you've got the correct battery. And well, here's a scenario. For obvious reasons, you can see they got the wrong battery in here. But you know, there are vehicles now that, because there's so many modules, batteries are important. And there's even some vehicles that are using these power modules to control optimized charging, the reduction of load or load deactivation, name a few of those things that they can do. And they have fail-safe characteristics and data memory. So when a battery is replaced, the module will need to be informed that it has. Now, another example of the sort of like controlling the power in the system and how it can affect particularly transmission diagnostics, Honda with the electronic load detector, the ELD. When this thing goes bad, which is, you know, obviously helps to control voltage output, on demand stuff. When this fails, you will get a host of solenoid electrical codes, and you'll never resolve them until you get that ELD squared away. So there would be an example of trying to diagnose your diagnostic codes and putting codes in certain priorities. Don't ignore the ELD and try to fix all these solenoid electrical codes. Get the ELD fixed first, get the electrical right, and then let's see if we've got solenoid electrical codes. You know, here's an example of bad grounds, what bad grounds will do. It will try to find a ground path through different parts of the transmission. You can have these bushings that look like moon craters, little pockets of explosion, taking out different parts of the transmission because it's looking for a ground path. Here's a scenario where this is like an Asian style setup where all the solenoids are grounded in the transmission through an eyelet and a bolt. So the computer is just hammering it with voltage, firing the solenoids with voltage. And the ground path from the transmission to the battery was compromised and continued to produce solenoid electrical codes. And no matter what you did, we couldn't fix it. And we actually ran a ground wire from the negative post of the battery right to the bell housing bolt to the transmission to ensure that we had a good ground, and all the solenoid codes went away. So we can't underestimate power and grounds, batteries. Make sure we have the right battery. Just don't want to underestimate that. And, you know, much can be said by doing a cursory view of the electrical system. Sometimes people mishandle the way they test computers and they open up wires. We've got fatigue wiring, water intrusion, self-inflicted problems, and sometimes the conduit may need to be peeled back to find disintegrated insulation. Now, obviously, I'm showing you on the left a Chrysler connector, on the right a Ford connector, and they're pretty much close to where they plug right into the transmission. But we've seen them go 6, 8 inches, 12 inches, maybe a foot and a half down the wire loom, and all of a sudden you just find a section of bare wires just touching each other. So, you know, doing some inspections like this, and when you have a lot of electrical code, it's good to be aware that insulation does disintegrate, and to be doing that kind of visual inspection. And sometimes doing a visual inspection becomes quite obvious. You know, you see something like this, you know why you've got some electrical problem. Now, another area that you want to watch for are these center consoles. Center console with the shifters, a lot of them have like little shifter computers in there, little computers for the shifter. And of course, you've got sunroofs, you've got coffee spills, soda spills. You've got all kinds of areas in which you can get water down in there and give us all kinds of problems, and you get water intrusion. I call it a little bit of broccoli growth going on in the connector and gives you different things, and you got to be looking for things like this and keep that in mind. Of course, some self-inflicted injuries is you know, laying down a pin, and you want to be looking for those things. You know, sometimes, you know, I hear where we didn't have this problem when it came in, and now all of a sudden we got all these electrical problems. Well, you know, I've been in the shop since 1974. I've been really in the shop almost full time, and I've seen some pretty wild things in the transmission shop. And sometimes the guy who's letting the transmission down on the jack, you know, he starts talking to somebody next to him, or he's just looking away while the transmission's coming down, and all of a sudden I see the transmission start to lift up off the jack as it's being snagged on the wiring harness, and all of a sudden you're yanking wires. And so doing some visual inspection, looking for pins laying down, looking for wires that are broken in back of the connector. Very good to do things like that. Now, many times, getting into another tip here, aftermarket scan tools sometimes are very lacking for transmission diagnostics. And the transmission industry has always been the red-haired stepchild in this way. And one of the main reasons is that scan tools cater to emissions control, especially when you've got 10,000 transmission shops and shrinking while you have 110,000 general repair shops and growing. It's an obvious choice as to the type of data the scan tool companies want to load up the tool with. But in these cases, when I'm diagnosing transmission issues with a scan tool that is not offering much in transmission data, I observe 4 main inputs, which typically can be found fairly with consistency in scan tools. And the first one, of course, is engine load. And of course, we're talking TPS, mass air, anything related to engine load, because it influences line pressure, shift scheduling, converter clutch strategy. So that's one thing that I'm concentrating on. The next thing is speed sensors. Obviously, speed sensors of any sort, whether it's engine speed sensors, input shaft speed sensors, output shaft speed sensors, I'll take whatever's available. Because the speed sensors have a tremendous effect on shift scheduling, converter clutch control, but it also can be used to check gear ratio of the transmission, which is also used to help for shift overlap, where we're releasing one clutch and putting on another, and that timing has to be right. Gear ratios are all determined by speed sensors, very important input. The third input that I'm concerned about is selector lever sensors or switches. We can have all kinds of issues. We can have no start, no reverse, no engagement, delayed or harsh garage shifts in the gear, no upshifts, sudden downshifts or neutralizing. I've even seen where the malfunction indicating light will come on, maybe even be blinking away, and you hook up a scan tool and there's no codes. And I've seen where that has been many times selector lever sensors or switches. So that's my third main input that I'm concerned about. The last one is temperature sensors, whether they're transmission fluid temperature sensors or engine coolant temperature sensors. Transmission fluid temperature sensors can influence line pressure and converter clutch strategy. Engine coolant temperature can influence shift scheduling and converter clutch strategy as well. And if these sensors malfunction, we could expect to have complaints of late shifts, flared shifts, loss of high gears, and or cycling in and out of the converter or no converter clutch at all. Now, this next point is another critical point in having in your mind when you're diagnosing, and that is sensors. How are the signals generated? A very critical point, because just because you have a sensor that's malfunctioning or a signal that's malfunctioning does not necessarily mean the sensor's bad or the wiring or the computer, but it could be the way in which the signal is produced. I'll give you a really good example. The Allison 1000, 2000, prior to Generation 4, has an engine RPM sensor in the converter housing. And so the sensor is actually reading on the torque converter what they call dimples. I call them hash marks because I think dimples go in, hash marks go out. But anyway, call them what you will, dimples or hash marks. But the thing is, these converters, they get bounced around. Now, here's a couple of examples of what can happen. On the left, you can see the dimple getting caved in. It got bumped up against something. And on the right, you can see that someone decided to drill a hole, drain the converter, and then they put a piece of weld right there. And now we got an extra reading to contend with. And now what we see here in a scope, what you see here on the left is the converter clutch solenoid actually briefly turning off. And so the converter clutch comes off, and then it comes back on. So the converter clutch, the symptom is a cycling of the converter clutch, coming on, coming off. On the right, you can actually see the engine RPM sensor where the actual dropout took place in the signal, which is what influenced the computer to make the converter clutch cycle in and out. So it's a great example of understanding how does a signal get generated, and the consistency. Looking at this with obviously a scan tool will tell you you've got an engine RPM sensor problem maybe, but yet it's not a problem with the engine RPM sensor. The scope nails it. You can actually see a consistent dropout. And when you see a consistent rhythmic dropout, it is a clue that the way in which the signal is being generated has been compromised. Here's another example with a Ford's FNR5 transmission. As we're looking down through the vehicle speed sensor hole at the exciter wheel that is used to excite the speed sensor. And you can see their tabs. Now those tabs, when you got that unit out on the bench, those tabs can bend down real easy, and now you got yourself an air gap issue, and you're going to have the same kind of problem. You know, you're going to have a miss in that signal because of that air gap. Now, of course, depending on how many of those tabs got bent down could determine the kind of problem that you might see with the scope. But again, it's always good to remember how is a signal generated. But now the next part that is critical in diagnosing is how does the signal finally reach the controlling computer, the one that's actually making the transmission function. How does that signal actually get there? Here, for example, is a 722.6 transmission in Mercedes, or they call it the NAG-1 in Jeep vehicles, Dodge and Chrysler. You know, Dodge Sprinters, you got the Chrysler 300, and all kinds of vehicles. And this transmission that you're looking at right here does not have a vehicle speed sensor in it at all. It is in the through the ABS, actually. The ABS is what actually calculates a vehicle speed, which is then broadcasted over the network to the TCM. Now this is interesting because that means that the computer is calculating gear ratio based on the input shaft speed sensor that it has. It does have an input shaft speed sensor, but then it calculates gear ratio based on what it sees via vehicle speed. So that means it's coming from the ABS over the network. We've had scenarios where people have changed the differential, and the rear differential, put the wrong ratio in. The computer doesn't know that, so the ABS doesn't know that. Next thing you know, we're getting constant transmission gear ratio error codes because of the wrong differential in the back. And again, when you understand how a system works and how a signal eventually gets to the controlling computer, there's a lot more that you can take in your diagnostics, and why, no matter how many transmissions you put in. Now, you could also put the wrong transmission in too. Wrong planetaries could do the same thing. Well, let's just say you know that the transmission was never changed. All of a sudden it comes to the shop with gear ratio error. You didn't ask if there was any work done prior, so you have no idea that the differential was changed, so you think there's a transmission problem. You take the transmission out, you really don't find anything wrong. You put new stuff in it, you put it back in the car, and you're still fighting gear ratio problems, so you change the computer, and you're still fighting gear ratio problems. Again, you got to take into the whole thing, how is the signal generated, and how does it eventually get to the controlling computer? Here's another example of a Lexus wiring diagram, just to show you. The red wire, or the red arrow, excuse me, is what's sending the vehicle speed signal into the instrument cluster. It's a Hall effect sensor. You can see it's a 3-wire.
Okay, that's it.
And it's sending that signal right into the instrument cluster. The instrument cluster then sends the signal to the computer. So now all of a sudden the computer's giving you a vehicle speed signal code, something wrong with the VSS, and you're playing around with the VSS and everything else. Meanwhile, you got a bad instrument cluster. So again, not only do you want to know how is a signal generated, but how does it finally get that signal to the computer that's controlling the transmission. The next thing is code classifications. I know I wanted to talk a little bit about code classifications, and And this is kind of helpful in helping you to prioritize codes. Of course, I use the electrical, which means just that. It's not the transmission, meaning internal like clutches or anything like that. If it's a bad solenoid inside or internal wiring inside, yes. It's anything related from the solenoid to the computer or the computer itself or the battery, things like that. It's strictly electrical. P0750, for example, with Dodge and Chrysler, very common, low reverse lockup solenoid code. And typically it's a bad computer, but we've had bad wiring. The point is to recognize that when you got an electrical code, the first thing you should think of is, do I have battery issues? Right away, battery issues, ground issues, and then, do I have wiring problems, solenoid problems, things like that. Range codes, I use P1120, the Ford code for TPS, and the reason why I bring that up is, let's just say you have a TPS with a range code problem, meaning that it's out of range. Well, that doesn't necessarily mean the TPS is bad. If the ground side of the TPS is compromised, you're going to be out of range on the voltage side, the signal side. So when you understand range, then you're also going to be understanding how is that signal being produced, and what could affect the actual signal itself. Ratio detection, like P0730, which is generic, it just means transmission slipping, something is slipping, which could mean anything from low fluid level, bad filter, to something wrong inside the transmission. If there's no speed sensor codes, it usually indicates that there's something wrong inside the transmission. But now, logic codes and performance codes, those are another classification that can help you to prioritize. Logic would be something like, you've stopped like 5 times, and the computer has watched that your vehicle speed went to 60 to 0, 60 to 0 5 times, but it never saw the brake switch signal. So you might get a code for the brake switch because logically it should have been there. Performance is obviously, like I use P0751, it's from GM, shift solenoid A. In other words, the computer commanded something to happen. It didn't see anything happen, didn't see an electrical problem, and so now that's where a performance problem comes in. So, it could be that there's nothing wrong with shift solenoid A. It could be something that shift solenoid A operates to make that occur, that shift occur. So understanding the codes and putting them in these classifications will really help you to prioritize and help you to diagnose your diagnostic codes, and then knowing how to use your scope and maybe voltmeter to try to locate where that problem may be. Now, another one is a combination of both electrical and performance, like P0871 that Dodge has for their overdrive pressure switch. That means that for some reason that switch is closing when it shouldn't, or not closing when it should, and it could be hydraulic, it could be mechanical, it could be electrical. So with that kind of a code, you really want to start your approach from the outside going in and doing some electrical checks on that signal wire. Again, the idea is to learn how to put codes in their classification, and then understand how to diagnose these codes by understanding how a signal is being generated, how is it finally making it into the computer, things like that. Now here's a simple example of what I was talking about. Take a Ford 5R55S and W. We got a P1715, a performance code for shift solenoid B, and we got P0733, a gear ratio error in third. Well, why don't we take a look at shift solenoid B, the application chart, and we'll look and we'll notice that shift solenoid B is only used to make third gear. Well, that's interesting. We have P0733, gear ratio error. Well, let's see what's going on in third gear. The next thing to do is look at a component application chart, and lo and behold, you find that you got the intermediate band is being used for third gear. So now you got one solenoid, one gear, the intermediate band. It's not coming on. For some reason, the intermediate band is not working. So before I think that I have a solenoid problem, or before I think I may have an internal transmission problem, I'm going to go to the intermediate servo to see if there's something wrong with the servo, which is external. So based on those codes, a simple example, but learning how to diagnose your diagnostic code and understanding how the system works, and to be able to make a reasonable diagnosis. Now, last but not least, I would like to talk about some self-inflicted injuries, transmission misapplications. Obviously, putting the wrong transmission in can give you gear ratio errors. We talked about that a little bit already. But, you know, there have been some transmissions that actually had AC pulse generator speed sensors that switched over to Hall effect sensors, and yet the connector, the case connector, is the same. You could pull one transmission out, put another one in. Next thing you know, it aborts immediately because of speed sensor issues. And we've had differences in transmission fluid temperature, changing the way it would operate from one year to the next. So you switch them out, and next thing you know, you got TFT issues, converter clutch apply issues, things like that. Now, we've already discussed programming issues, fluids, compromised connectors, pinch wiring. Some of the things I want to say about compromised connectors and pinch wiring, you know, sometimes what happens, as I see, is that the weather pack seal around the connector maybe has gotten some fluid on it or some battery acid on it. You know, you unplug it, next thing you know, the thing just balloons out, and now you can't plug the connector back in. So I've seen the whole weather pack seal just thrown away, and you plug the connector right back in without any weather pack seal, and now vibration, this thing starts vibrating. There's nothing really holding it tight in place, and you start getting intermittent problems with sensors. I've seen where the locking tab gets broken, and the way people jam the connector in there to try to keep it in place. So, you know, sometimes we do have those kind of self-inflicted injuries. But then connector cross-connect, and I always try to make known in newsletters and bulletins and articles about all the various ones we run into. There's tons of connector cross-connects that just beat everyone up, and it's never in your thinking, in your diagnostics. And I just thought, you know, some of the popular ones that we see are speed sensors and solenoids. So those are the two most popular. I earlier talked about the Eisen-Seiki 68RC. There's a cross-connect that can happen with that one between solenoid connector and the transmission range sensor connector. They're right next to each other, identical, and you can cross-connect them. But the most common ones are either speed sensors or solenoid. When you cross-connect speed sensors, here's one of the ways that you can identify this. Typically, you have no reverse from park, but you have reverse from drive. And that's because when you're in park, because you've got maybe an output and input speed sensor cross-connected, as soon as you start it up, the output is spinning. And the computer is thinking you're moving forward. And there's a safety feature that after so many miles per hour forward, if you go to reverse, it won't let reverse engage. But as soon as you go to drive and your foot's on the brake, everything comes to a stop. And now when you go from drive back to reverse, you'll have reverse. That's a telltale sign that you got your speed sensors crossed. You also may notice that you'll see a speed signal on the instrument cluster that increases with throttle opening. The other is solenoids. And when you cross-connect those, sometimes you have irregular shift patterns, you have stalling, you have a no reverse condition. So in summary, you know, some of the things to remember is to ask those unusual questions. Make sure you ask them. And the customers do not want to give you the answer. They're afraid of that big bill, but you got to work it out of them, you know, and do a complete health check of those, of the computer system, and learn how to diagnose diagnostic codes, and make sure you test the batteries. Again, power and grounds and the state of the battery charge and being able to handle load is critical. Checking tire sizes is critical. You know, stay mindful of those center consoles, and keep in mind those 4 main inputs if you have scan tool data that's lacking. Remember engine load, remember vehicle speed, remember transmission range sensors and temperature sensors. And then, of course, using the code classification technique to help you in your code prioritizing and diagnosing code. So once again, on behalf of ATSG and our sponsors, I want to thank you for your attendance this evening. Powertrain Pro is very proud to be helping over 80,000 independent shops across America trying to stay profitable in their shops. Thank you very much for your time.
Wayne, thanks a lot, bud. It's been a very interesting evening here at Motor Rage Training Webinars. First, a big thank you to all the guys that hung in there with us. You guys are absolutely the greatest. There was some mass confusion there when the audio signal dropped out. Wayne is blissfully unaware from his remote location down in Miami of all the fun that was going on my end. But I think we got through it, and we learned from that. You know, very first time we had this problem. It's not the first time we've used this platform. In fact, Wayne and I just completed going through this entire process just a few nights ago to make sure everything worked. And everything was working moments up until we went active on YouTube. But because this is a Google YouTube platform, we were able to make the transition fairly quickly, and with a little help of one of my IT friends out in California. He did get the player installed here on the Motor Rage page to help alleviate or minimize the confusion. So again, all you guys that stood out with us, I really appreciate it, and we will make sure that we learn from this experience so that our next webcast will not suffer the same issue. I do have a couple of people. I got some people watching on the Motor Rage site. I got a couple of people, or not more than a couple of people. I got a bunch of people watching on Motor Rage site still. A lot of people watching on the YouTube page. We're going to take some questions now for Wayne. So if you have any, go ahead and comment anywhere you want. I will bounce back and forth between the three to make sure we catch them all. For those of you who had some issues in between going back and forth, of course, like all of our webinars, this will be available in its entirety for viewing anytime that you want, which is another one of the benefits of the training that we try to provide for you. I know Wayne works very hard at developing great content that's going to be helpful not only to his normal audience of the transmission specialists here in the country, but also for us regular guys that have to take care of the rest of the car. So, Wayne, again, I appreciate that effort. All right, so questions, guys? Well, so far so good. Looks like most people are pretty good. Again, thank you so much for hanging in there, guys. I don't see any questions pop up. I'll give it a couple more minutes. I know Wayne has been struggling with his laryngitis today. Yeah, Gio, thank you. We'll repeat everything we just said. But you know what? I'm going to let YouTube do it on autopilot for me. If you go to where the player is embedded now, you'll be able to watch the whole thing in its entirety as soon as we end the live event. One of the beauties of this platform. Wayne, do you have anything else you wanted to add in closing? I'm going to show your ugly mug there just for a minute so everybody can see you. Well, I was hoping there's a little glitch there too. There we go. There he is, all there and down in Miami. We'll let him finish out the screen. All right. Well, it looks like we got everybody taken care of. So, hey, Wayne, I'm going to say goodnight. Thanks so much, for your hanging in there, getting through the night.
Well, it was my pleasure, Pete.
And guys, I want to thank you two for hanging out. One last comment we'll take. Yeah, actually, I'm glad we hung around for that one because I'm sure Wayne will agree. Yes. Joe mentions that if you do have shorted components like transmission solenoids, solenoids on the engine side, sensors, they can lead to damage of the PCMs. A lot of times guys pull a trigger, and I don't know about the training side, Wayne, but sometimes we pull the trigger on a control module on the drivability side, and we fail to check all the inputs and outputs to make sure that we know why that PCM failed. It's not like the old days, right? I mean, you know, they don't fail with the routine that that they used to.
Yeah, that's very true. And you know, we've had situations like there's a transmission called the JF506E that's used in the Mazda. It's used in Volkswagen, Jaguar. It's used in quite a few different vehicles. And there are these two solenoids that are in the bottom right-hand corner. When you take the side pan off, bottom right-hand corner, the connectors are right there. And you can accidentally get those wires pinched on the pan when you put the pan on. And now you got a direct short. And as soon as that computer operates those solenoids, the computer's blown.
Wow.
And
Wow.
and so if you don't understand that, you go and change that computer, and as soon as you start it up, it blows again.
Yeah, you just bought a new computer. Yeah. Well, in that event, I can hear his voice going, guys. I'm going to have to cut him loose. Of course, again, stick with us. We have, boy, I tell you what, I won't make Wayne respond to this, but I've seen some of the plans that we've got for next year. Believe me, putting up with some of the glitches that we've had as we've gone through our learning curve here. I mean, after all, I'm a mechanic. Wayne's a transmission guy. Neither one of us are video producers or TV directors. Yeah, we will. We have some really neat stuff planned for you. So, you know, if you're not subscribed to the Powertrain Pro newsletter or the Certified Tech newsletter, get on board so you know what's coming up and when. And with that, Wayne, I'm going to say good night and have a great evening down there in Miami.
Very good. Thank you. Good night, Pete. Thank you for everyone's attention.